What a good idea
Hey
about
everyone,
it.
well, Drew is tagging along as well. And as you may or may not have guessed from the title of the stream and the description, we're going to be swapping in a model from Ocarina of Time. So
Hi, people.
this is kind of the first time that we've attempted to do this. We've swapped out textures, we've swapped out sounds, but we've never been able to do anything with models before. So we're going to be kind of experimenting and seeing what we can get going. So Doom has graciously ripped the treasure chest model for me from Ocarina of Time. I figured we'd start with that because it's a very simple model. It has the same number of parts as the regular Legend of Dragoon model, so we can use the same animations. And let's just jump right into this. So we're gonna be using a tool called AsImp. That is the actual name of it, short for Asset Importer. And that's gonna be how we load the models. So I just need to grab that. I think we should just be able to bring it in like this. What's up, Mr. Homebrew? What's up, Super Ghetto? What's up, Chocolate? What's up, anyone else who is here? Alright, so we have ASIMP. So we just need to look at the documentation to see how to use it. Alright, so we're going to be using, what's it called? Doom Colada model format?
Yeah, the Colada, let's gonna say Colada format that file. Um, Actually, the complete name of this is, let me check a little bit. Um, um, well, um, let's gonna say like a 3D asset exchange schema. So it, that will be the actual name for Colada. It's like interchange file type for 3D. So, well, it's very good because you have like different like games, 3D engines, um, 3D software that use actually Collada in their specifications. So uh, we will have like a lot of, if I can tell, like compatibility with very much of the 3D software going on out there.
Right.
So it will be good.
So you said this is the very first chest in the game?
Yeah. That's the very first chest, and then they comes to like two south for them. So
Okay. So I'm going to add some special case handling in here.
mm,
What was it? 264. No. 264 divided by 33. is 8. Okay. So we need to pull this out of here. Alright, so now at this point, this will be loading that chest, so we need to figure out how to use ASIP.
That's the interesting part, I think.
Let's see what we've got here.
Load? Something like load or... Whoa. Oh yeah, I read a little bit about the A type of. I think you might use import file. It's a little bit up.
I think we want import from memory.
Okay. Yeah, make more
Let
sense.
me see. So what is the difference between this and the file? Because they both take a byte buffer. Oh, that's a byte buffer containing the name of the file. Okay.
In other words, you go for the string or for the actual tree data inside memory. Yeah.
So we just need to wrap the incoming file. Actually, no, I mean, we could just, yeah, I'm just going to load it from disk because that'll be easier.
For now.
I'm just going to drop it in the folder here. Now, is this going to need a absolute path? That I'm not sure of, so I'm just going to give it one.
If one crash, it is working, you know?
Okay, so flags. What are flags? Read file, calculate tangent space, triangulate, join identical vertices, short by type. I'm just gonna pass 0 for flags. What's the worst that could happen?
Okay.
Now, what are you? Oh, because I didn't switch that.
Oh yeah.
Cool. Wow, I can't type.
Okay.
So that gives us a scene.
Yeah.
And we are going to need to do something with that scene to convert it into the LOD format. Well, not the LOD format, but the format that the actual renderer uses. So we're going to need to extract the vertex data here. So I'm guessing this is going to be meshes. Let's see.
Yeah, you first need the meshes because inside this scene you got different meshes split. In this case, you will find the two objects.
Yeah, it's returning a pointer buffer though, so we're going to have to
Oh,
figure out what to do with that pointer buffer. Root node. What does the root node give us? index into the mesh list. Okay. How do we work with meshes? All meshes in an imported scene are stored in an array of AI mesh inside the AI scene.
I think in other words, it's telling like meshes is actually the objects you got in the same like.
Yeah, I'm trying to figure out how to use the meshes though, because it's just returning a pointer buffer.
Mm, yeah. So you need to extract the other information.
Um, hey Ninchi, how's it going? Okay, let's just look up LWJGL ASIM. Why is my default search engine Bing?
Well, obviously, it's about taking at least a little power away from Google, right?
Fair enough.
You ever seen that YouTube series, A Google Guy?
No, I don't think so.
It's the people using a Google search engine if Google was a guy at a desk and the people physically sit at a chair across from them at the desk. And they, say their queries. And he hands over papers or no results. And it's funny. But in one of the episodes, they actually have a door down the hallway for Bing, and it's a comedian I can't place the name of who's just like, "We're ready, guys. Anyone? Hello?"
Oh, hey Jeff, what's up?
I'm gonna
Oh
post
yeah.
that off topic, I think.
I I recall that. I thought it was like a kind of advertising. But actually it was like a series. Holy shit.
Okay, so I think this is how we load a mesh from ASIM. Okay, so we have faces,
You are looping through the
we
three
got
meshes,
vertices.
and then you got the vertices, the normals. Okay.
Actually, let me take a look at that. What's up, Psychronics?
Yeah, pretty much. It looks like the logic that is behind Blender scripting, because in Blender scripting you need always to like looping inside the meshes, the number of meshes.
Yeah, yeah.
Um,
Alright, so we're gonna need to do a little bit of hacking here. Because we've got the C container, which is what the actual model is stored in. So we need to we're gonna have to modify this. Okay, so let's see how the model's used here.
Mhm.
Okay, so we will add something else so we can kind of pass this model along down the line. Um, so I think instead of doing this here, we're going to get kind of hacky. We're going to just add an extra variable to this right now.
As a flag.
This is going to be,
New
I'll just
model
pass
flag.
the AI scene. Um, and we'll add a new constructor. And we need to set the pointer to null and the other two extensions to null as well. We'll come back and do something proper here at some point, but for the dev stream, we don't do proper because it takes too long. So I'm going to copy that code where we were just getting ready to process things. And so if submap assets.objects.get I.model is not null, then we do this, else we need to process the scene.
Mm.
Alright, so we have mesh index.
Okay.
Yeah, Chocolate says the LOD devs never did anything right anyway, so it fits right in. I'm not going to disagree with
Oh, that's not fair.
you. I mean, the scripting engine they wrote was pretty cool for the time.
Mm. Yeah, also some other stuff are pretty much good, but they maybe fail in the code implementation, but the idea behind it was very good.
They
Um,
just needed to practice on something smaller before going straight into grand ambitions.
Yeah,
yeah,
exactly.
Like, I
This
have a
is
dream project. I would love to build my dream project. I've done some work for my dream project, but I keep it on paper until I have more like concrete, real experience with smaller stuff.
yeah, that's that's very important. Yeah. Oh, okay. Uh, okay. Now you're loading the.
uh, yeah, Ubermedic. We're basically just using this model for testing. I mean, it's an Ocarina of Time model. We obviously can't use this or distribute it or anything, because we would get a C and D, obviously. But yeah, so we're doing this to test things. We're kind of just using it as like a baseline because it's a simple model. It's something we can easily get our hands on, and it's very similar to the LOD model. But this work will allow us to import any model.
Hmm.
So, that's kind of a little bit more important. Okay, so We have a mesh, and the mesh provides us with faces, colors, etc., etc.
Yeah. So now you're reaching that part. Okay.
So we're gonna have to kind of model this after the LOD code. Now, this is some heavily modified LOD code that does a lot of things in a better way, but we do still need to provide something in a format that our renderer can render. So, now, unfortunately, it is setting the TMD directly here.
Mm.
So that's a bit annoying. Okay, so we've got that null, so we don't need to worry about this chunk. What was objectivity to? Okay, so I think this is actually the only place that that field is used in this case. We might be able to get away with just setting this to null,
No.
since obviously we don't need to
Yeah.
call that at all. Okay. So, time to get hacky.
I know how you like, you know, that word.
Okay, so we are loading async model.
Yeah, at first I thought that you need to load like specifically DAI files, but actually the same system seems to be loading anything in the same way. So no matter the format, it would load like in a generic
Yeah,
scenario.
exactly.
That's very good. So maybe some people could use some models from FBX, I think is the model format. VX.
Yeah,
Yeah, pretty much.
that's the benefit with using something like ASIMP because it's just like a universal library, so it supports a bunch of file formats.
Mm, yeah.
I think we're going to have to do something with this, but I'm not 100% sure. We'll get into that if it crashes. Okay. Um, so model.tpage108, we're just going to set that to 0 because we don't have anything there. Pointer A8 null because we don't have any of this. I'm going to copy this as well. So now we need to do the big thing here.
Yeah.
Okay, so where is model.count being set? Is that upstream?
Oh,
No, okay, that one's for combat. Maybe here. Yeah. Okay, so init model is being called, right. Okay, that makes sense. That's being called from this. Um, so we're going to do this first. No, we don't have the C container. So we need the number of objects, which we can access with scene dot number of meshes.
That makes sense.
Okay, so that sets up that entire thing there. I think, yeah, we can just call this method directly because this is not dealing with TMDs. Yeah, we can copy these as well. This is just initializing the actual in-game model, which is not attached to any kind of file format.
Yeah.
Now this, prepare object table 2.
Well.
Let's see what's going on in here.
Yeah, in there you got a lot of matrix working.
Yeah, so we're actually dealing with the TMD model. So I think we're going to have to. What are we gonna do?
Oh yeah.
I think we'll probably swap. Maybe just make a copy of this method and pull in that uses a scene rather than this. Okay, so we're using 800, 200, 100. 821. Okay. 1 is fine, 1 does not use the TMD. Table. Okay, so that's after it has already been processed. So I think this is the only thing that needs to be swapped out here. Let's see how many places this is used. Okay, so we're just going to do something kind of silly here. We're going to make this nullable, and then we're going to add another nullable AI scene. And yeah, let's backtrack here and make this nullable as well, do the same thing. Whoops, I put that in the wrong spot. There we go, and then we also need to update these. Okay, this is the model loader that we are currently looking at. Let's just do the others and leave that. Okay, where is this used? Okay, that's used specifically for loading the player model and loading something via script. Okay, so in this case, we'll just pass null. And in the combat one, we will also just pass null. We will revisit those later. Okay, so that leaves us with this one. And yeah, so, right, we're passing null there as well, and then in our new version of this, oh, we're still in smap here. In our new version of this, we can pass null for the TMD and pass the scene in here.
The scene. Right, so it will work. Okay.
Yeah, now we need to do something with this. I'm going to split this if statement, and we're going to say else if scene is equal to null.
Oh, yeah.
So here we need to actually do the loading. We need
Okay.
to convert this scene into a TMD object table.
Well, I think that's pretty much like unconverting the the Collada file. Um, yeah, you have some way to split into vertex normals, vertex colored,
Yeah,
that stuff.
we can access that stuff here. Okay, so
Well,
TMD object
I think I
table.
pretty much. Yeah,
So
that's
yeah,
the
we
order. For yeah, the array. Um, I lost the primitive. That actually a primitive is like a face, so it will be representing the same.
yeah.
So
Yeah, so we are going to have to come up with the primitive ID for each face.
oh yeah, that's why I didn't start my like my reconverter from Blender files into TMD because I need to figure out a way that like insight from Blender detecting which face will be of some type, so by creating generic like primitives.
Why? Oh, okay, so it's already got the face created. Does it? Hold on. What's going on here? Okay, what does faces return? Okay, so the face is already there. That's a bit easier. So we can get the indices of the face.
Nice. Well, um, it will depend which type of value you expect the TMD object table. I think the array. I don't know. It's waiting for bytes. Surely. Yeah.
Should be doing this here. Okay, so actually I'm going to uh, convert acid mesh to TMD objects table. Okay. So where are we here? I'll paste this here real quick. So we've got the scene. This is some real dumb code. It's why? It's looping over these, but it's looking for a specific index. It could just use the object ID -1 and not loop at all, right? I'm not crazy, right?
I think you're not. Um, it's like the way that I'm working with the primitives in the generic way inside my TOG code for the converter. I generate like an array and from the same spot.
Okay, so I mean that should let us do the exact same thing here. I'm pretty sure this is going to be object ID -1. We don't need to loop over the meshes because we're looking for specific ones. And I just realized another thing. Why is this even returning an array? This should just be returning this. And then we don't need to do the array lookup here. Okay, apparently to myself while you're gone. Okay, so the thing that's going to be a thing is actually converting this into a object table. So we need to get the vertices, the normals, and the primitives. Okay. So each face is going to be a primitive. So we need a list of vertices. What rendering configuration each face needs. I mean, we might just be able to use a generic one. That's probably what I'm going to do. It'll make it a lot easier. If we go to the no cache documentation, we go to the GPU and the polygon rendering commands. Yeah, we'll probably just use the 3 and a 4 point polygon commands here. I guess we'll be using these ones because they support everything. Alright. So, we need to add a new primitive. The primitive needs an offset, a width, the header, and its actual data. Okay. So
Every time you say primitive, it reminds me of Second Life because that's the terminology we used for building objects before we had mesh tech.
Yeah, that's what it's called in rendering. They were probably just used the rendering term.
Yeah, so we ended up getting the shorthand of prims everywhere. Like any region you went to, it was a big rectangular space, and it could only hold so many prims because server resources. And so the cheaper regions would only have like 3,700 prims available, but the expensive regions would have like 15,000 prims available. Basically, you just put more stuff on it, and it was just a constant thing to try and figure out how you can make your space, because it's kind of like The Sims. You could put a house, or you could put a giant pirate ship if you wanted, and it's about making sure it doesn't take up too many prims, but you still want it to look good. So there was that whole process until Mesh came out and made things a little easier.
Yeah. Yeah, that's a pretty common shorthand as well.
Prims.
Yeah.
I'm back.
Welcome back.
Thank you.
Really
So,
quick story. While I mentioned it, the community had started transitioning to Mesh already by the time I had learned how to build, and I could have learned 3D modeling, but it was a barrier of entry for me, so I stuck with Prims. And while everyone else is trying to figure out how to do Mesh, I was doing really cool ways to try and optimize prim usage by like taking a window frame, and instead of putting 4 individual, rectangles, I would have one rectangle that has a cutout in the middle because that was one of Second Life's features. So
Yeah.
I cut that down from 4 prims to 1. And I had this slogan. I had this little prim palette, I called it. And it was for people who wanted to learn how to build with just prims in Second Life. And my slogan was, why be meshed up when you can be prim and proper?
Ha. And that's all under
I,
you.
I stood by that for years. And now everybody knows.
Nice.
Alright, so the offset is only used in the submap collision code. That's not something that we need to worry about, so we can just set it to 0, which is good because we don't have an offset. The packet width is either going to be...
Oh, yeah. The classic one.
Okay, so it's either going to be 36 or 48, depending on how many vertices we have. Oops, I wanted base dot number of indices. So this will hopefully be either 3 or 4. Doom, when you generated this model, did you keep everything as triangles and quads?
Yeah, exactly
Okay,
the
good.
same.
Okay, so it's
Yeah.
all triangles and quads, no faces with more vertices than that.
Yeah, no, duplicated vertex, no. I don't like them. So, um,
Okay, so
so you are going to like working into at this right moment as generic primitive to be converted, if I'm right.
let's count is 3, then the size is, oh well, I don't need to do that. I just need to do index count times 9.
Yeah.
Because, yeah, 36 times either, wait, oops, wrong window. 2.
And if you're asking, yeah, this thing is pretty much big in the original.
Yeah, no, that's not 36 or 48. Okay. So we have the primitive width. Hey, Ontario. Yeah, it's going to be very interesting. We will see what happens. Um, okay. We need to pop open the file format here.
Here in the chat in Discord, the Black Watch, I call it, tells that GLTF is greater than die file. Yeah, maybe I sound a little capricious about this using die file, but I'm using it because in the time that Tilot was done, Sony was one part of the collaborative, like talking people in die file format in Chronos. So I think we will find that it's pretty much compatible with we will finding in TMD as in the die file format. It's pretty much the same the way that the file is handled in, like I mean in the like raw data type of handling. So That's why I was about to use GLTF file type, also Ply, uh, PLY, because they're pretty much similar too. But I think that like that also you can get the um, not only animations, but in the future we can add the possibility of a generic skeleton for the models. That will help a lot to people that like are modding a model. They send all the package inside the dev file, and if you find something, you can like tweak it, and then you can share again. Maybe I don't know if GLTF format had that kind of like features inside. To be honest, I didn't research too much, but yeah.
I need to figure out the proper header for this. Okay, yeah, so shaded is that higher bit. So it should be
Well, you could use some
3E.
generic like source calculation. I can give you the original one type of primitive if you want it.
No, I know what we're gonna use here. It'll be 3D04. Or for the no, that's the quad configuration. For the triangle configuration, that's gonna be 3.5. Pretty sure that's right, because this 4 here enables recoloration.
Yeah.
Okay, so now we've got our header, and we just need the data. Now the data is gonna be a thing. The data is the hard part.
Yeah. You must build the array here.
I think I might actually disable color for now.
Yeah, from what I expect, at least for this very first model, is fill texture, so coloring is disabled by default, I think.
Yeah, I'm just gonna ignore that data here. Um, yeah, let's make this as easy as possible. So we're gonna use 3C configuration for the quad. That'll give us vertices normals. And we'll use 3.4. And yeah, we don't want shaded. Okay, good enough, good enough, good enough.
Yeah, something that here Hunteria is asking, pretty much interesting too. Not only the custom models, but also higher fidelity models. It's pretty much the idea behind this, getting some a little more like quality models. Um, but as always, the first attempts will be with simple models to know how the engine will behave. Be sure that it's loading correctly the files. Also, what we're gonna do for like tweaking the models before loading into the game, because in this case, the Legend of Dragoon is using not only a model but different format that specs the model in certain position. Um, so we have to experiment a little bit about this. And once we get some clues on how it's really behaving, we can add anything we want. But first attempt. Okay.
Yeah, this is the start of that.
Yeah.
Okay, so now we need to build up this rendering packet. So we need the UVs. So our face gives us the indices. Does not give us anything else. I assume the vertices will point towards the normals and everything.
Yeah.
Okay.
Yeah. Pretty much. Um, the idea behind the indices is to like find the data into the array, so um mm, mm,
Um, this is going to be index because graphics programming.
yeah.
Okay, so we have array. So I think we should be able to do this. I think. Well, int vertex index. So now if we go back to the mesh, vertices.get vertex index, final AI vertex. No. Okay, what type is this? AI vector 3D. Well, no, this is only giving us the vertex itself. So I wonder if the normal arrays are like a parallel array or something.
Might be able. Let me check. I'm gonna pay.
That is materials, process, mesh. Okay.
You must having like inside the object. I'm reading a code right now from Stack Overflow. Seems that the moment that you get the num of meshes, you can call directly into that to get the vertices, the UV and normals. But here is using a method that I don't know if the correct. Mm,
Loading the vertices, that's the buffer. Okay, that's loading them into just a list of floats.
Yeah.
Okay. Each vertex is associated with 4 weights, blah 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 blah. Okay. Some riveting television.
Alright.
Okay, so in this case, I'm actually going to run this, and we're gonna see what happens. We need to move this C container out here. So I'm just going to run this code, and we're going to load up that map just so I can see what some of these values return. Obviously we don't have working code yet, but I just need to be able to see what's going on.
Cross finger. Wow.
So maybe I should actually put this breakpoint back here. So we'll go into the initial loading code. Did not like that at all. Where did we call? Okay, so why is that null? The TMD pointer is null. What did we mess up here? Oh, what we messed up here is that is the correct check.
Okay.
Alright, let's try this again. Okay, so we've got our breakpoint here. So we've got the AI scene.
Yeah. The address to the scene.
So now, our count is 4. Does that make sense to you? 4 meshes?
Yeah, in the first loading, yeah.
So there
Or
should be 4 meshes here?
no.
Well,
Must be 2.
we're off to a bad start then, aren't we?
Well, twice, which is good. I don't know if I don't know if there is some kind of thing going on with the quads. Maybe it's like converting the triangles into the quads into triangles, and maybe that's why the split of the mesh. But I'm not sure.
That's bad though, because we need to have the same number of objects for the animation to work.
Yeah. You have a way to.
So something is already weird here.
Number matches. Hmm.
Alright, so that's a problem. Let's
Yeah.
jump down here to where we're actually doing some stuff and see if we can find out any more information.
Number of object goals.
Is this test to load a DAE format file?
Yep.
Yep.
Okay.
That
Only if.
nothing happened there at all. Okay, TMD number of objects is not getting set. Where is that getting set here? Right there, okay. So we need to set that. Okay. So we want to say, we do want to set the TMD to null. And then TMD number of objects equals, that's going to be the model dot count, I believe.
Yeah.
Let's make sure. No, okay. So model.count should actually be getting set to the animation file dot model part count.
Okay.
Okay, let's make sure we're not missing anything here. Wait, this is not the same method we were looking at.
Yeah.
Hold on. Okay, so there it is actually getting set to that. But that value should, well, that value has to match.
With the number of objects inside
Yeah.
the. Also, I checked the entire file, and it's correct. It's two. So somewhere it's like duplicating, maybe.
We got something weird going on. Let's try rerunning this now. Ninja asks, how many lines of code is separate chains? That is actually a really good question. There are multiple classes with over 10,000 lines of code each. I would estimate it at probably being around, if you remove the spaces, or if you remove blank lines, probably around 20 or 30,000 lines. But that's just a rough guess.
Right. Okay. I think, yeah, maybe we are looking first.
So that is this one. We need
You got. Oh,
we need number 2 here.
yeah. Because it's loading.
Okay, so we're jumping in here. So we get to look at the. Let's see how many faces are in this first one here. 20. Does that make sense to you?
A little bit. Let me check in the file itself.
Yeah, can you verify that?
Yeah. Let me.
Yeah, it is a lot of lines. It took a really long time to write them all. But yeah, that's pretty standard fare for a game. And I have also removed like tens of thousands of lines of the I'm talking words. Tens of thousands of lines of like library code and PS1 kind of like pretend emulation layer code.
Faces. The number of faces that you got was 8. Oh yeah,
Uh,
you got the size of
Number of faces is 20 for the
20.
first match. Does that make sense to you?
Uh, for the first one I got 10, and the second one, let's give a try to the second one. Uh, can you run it into the second one, maybe? Okay.
This is somewhat concerning.
Yeah, because it's duplicating. I got 10 faces, not
How many
20. So,
vertices do you get in the first mesh?
uh, 16. 16. So
16?
yeah.
I've got 60.
Okay, that's pretty much it's a lot of vertex, but let me check all the vertex. Yeah, I in all vertex from all the object I got uh 67. So
Okay, let me take a look at. Okay, mesh number. The second mesh is 16 faces.
the second mesh is actually 36 mesh 36 faces.
What is
Pretty pretty.
happening? And I've got 48 vertices there.
Yeah, maybe there is some.
Okay, so for the next one after that, I get 6 vertices and 2 faces.
Okay, okay. I think it's splitting all the object into their faces, like doing something weird.
And for the
Because
last one, I'm getting 8 faces and 24 vertices.
okay, the sum of all of them. Oh, how much is? Because maybe it's splitting all the stuff. Maybe it's splitting into quads and triangles and splitting the object from there. Like it's sub-splitting the object. You got two objects and it's splitting one into triangles and quads, and the other one too.
Okay, so I'm looking at the file here,
Yeah.
and I'm seeing positions array count 153. So I'm assuming that's X, Y, Z.
Yep.
So that should
You have
be
it for your 3,
51.
and the count is right there. Yeah.
Okay, so
You got
yeah,
the
so
count
51,
51,
51
36.
vertices.
Yeah. For the first block.
Positions,
Okay.
normals. What is map 0? Is that... Okay, that's ST. Okay,
Yeah, yeah, that's the UV count.
yeah.
And
Alex
then you
Jones
got,
says, I count 90K LOC, so yeah, 90,000 lines of code in RB2, including blank lines.
yeah, the first time I recall that Monoxide got a lot of like optimizations in the code at the very first week.
Yeah, well, do you remember the very first recording that I did of a submap with the floating rose head that was running at like 1 frame every 2 or 3 seconds?
Yeah, that was like real art, you know.
Yeah. Okay, let's see if we can make sense of this. Okay, number of faces is 20. So I mean, I'm seeing 20 here,
Mm,
right?
yeah, but that's the front material. That's counting the material. The total for like the stride of these triangles, you know. Counting as I told, is counting first the triangles and then the quads. But in this case, you got all the the triangles only. It's a little weird how like
Yeah, I'm not understanding. Um,
yeah, Blender will read something about that, and the actual like data inside the div file could be a little different. In this case, from material.
so what is this data here? This is not just...
Yeah, that's the faces. The faces count, but for some reason you got 20 and 60, but here I don't get the same.
Well, I'm like it does say 20 and 16 in the file itself.
Yeah,
So, what
maybe
is front material and wood material?
the front material will be the where the logs go down, and the wood material will be like the crate itself.
Okay, so this is why we're getting... Yeah, this is why we're getting 4
Oh yeah,
objects, because there's 2 objects there and 2 objects here.
objects here. Yeah. Let me check. It says strangles and other treasure chest. Let me check the other one. Below. There in the file.
Sorry, what was that?
Yeah, in the div file to find this. What's it telling? The accessor. Okay. Content, count 30, and in the end, in the triangles, after a little bit down below. Oh yeah, triangles. Okay, yeah. For some reason, it's split. Ah, okay. I know why the count is different in this case, because it's using 2 different materials for the same object. So it's splitting like the materials instead of having a single face count, you know?
Okay, so
Um,
that's gonna break the animation.
yeah. For some reason, it's reading like that. I didn't expect to find something like that. Maybe I should do very fast uh, merging of the texture and the materials here.
Yeah, I mean, if you can do that, then I'll just keep working on
Yeah,
the code here.
yeah, it will take me a minute.
Alright, well that explains why we're seeing this weirdness. It is not actually weirdness. It is senseness, I guess.
Yeah.
Um, okay. So this is correct. This is what we are expecting to get. So that's all fine. Yeah, we don't need to worry about that. We just need to figure out how this works. So I'm wondering if these are interleaved. Doom.
Yep. Sorry.
In the triangle output here.
Yeah.
So this stream contains all three of these pieces of data.
Yeah, exactly. Yeah, that's the array. First you
Okay.
got the normals, then first the vertex, then the normals as the text core, and if the model have color mapping, you will find another semantic telling colors and the placement inside the array.
Okay, so
See?
this is it one after another? So it's all vertices, then all normals, then all text chords?
No, it's vertex, normal text core, and colors is if exist, end of that array, and then start the next one.
Okay, so it repeats.
It repeats exactly.
So is it going to be X, Y, Z, normal X, normal Y, normal Z, and then ST?
Yeah, actually, in this case, the vertex in here will be representing by 0. That
Oh,
offset
right, it's
0.
the index.
Yeah, is the index, and you will find all the data in there.
So this
Yeah.
is going to be vertex index, normal index, and then
Exactly.
text chord
Take 0.
index,
Exactly.
and then vertex normal text chord, vertex normal text chord.
Exactly. And it will get repeating for each one of the counts.
Right, and then there should be 20 of those.
Yeah, it's a little bit tricky to like counting them. I tried before with Notepad++. Okay, I will keep this like okay. Let me check this one last. We'll getting another split area. Sorry if I'm talking, but I need to yeah, I need to join these two guys into a single one.
Okay, so index
Single.
count, face count first. How many faces do we have? Okay, so we have 40. That does match up with what we got in the file. Okay, so that's good.
Okay. So, okay, and I will open up this one.
And okay, so I guess the number of indices must map to how many of these there are. So it says there's 3, so it'd be vertex, normal, and text chord.
Yeah, it's one by one, and makes sense somehow. Makes sense. Fine, I think. Okay, now I getting
Okay, so
weird.
this is not correct. So our index count is not actually...
Counting the index. What surprise.
So,
FB.
final int vertex index equals base dot indices dot get 0, and then we have our normal index and our text word index. That's going to be 2 and 1. Are these all triangles?
Which one? Let me check.
Just
Yeah,
everything?
are
It's all triangles?
yeah, it's converted into triangles.
Okay, so that is even easier then. We don't need to worry about quads at all.
Okay, we got this one, I think, working. Let me check very fast. Because I need to check the texturing is correct. Should, I need to import a new one. Take care of this one. This,
Okay.
okay, it's twice.
So I think we have our vertex, normal, and text boards now.
Nice.
So it's giving me a long for the text boards. That might be a pointer.
This one will be a little tricky to get.
Okay, so now we need to assemble a packet here. A TMD packet. So we're doing 34, which is a textured triangle. So I'm just going to use zeros for the texture coordinates and stuff for now. Okay, so normals come first. The normal is an index into an array just like this. So I think we can actually use the exact same indices here, which is pretty nice. Now the thing is, we need to split these into bytes, so this is going to get a bit messy. No, you know what? Instead of doing this, I'm going to do this an easier way. This is 4, 8, 12, 16, 24. Wait a minute, why is this 36? Should that not be 4, 8, 12, 16, 20, 24, 28? Am I missing something here? Hold on, okay. Let me just make sure that this is sane. Yeah, no, I was doing, when I did this math before, I was doing the math on the GPU packets, not the TMD packets.
Oh.
Which are a moderately different format. Okay, so that makes sense. Does this include the parameter size? I do not remember. Let's just do the math. So it's a quad, so 3 bytes vertex count times 2, so that's 6. It has normals. It is not shaded, so 2 more, 8. It is gradated and not lit. So another 12, that's 20. Textured. So another 12, that puts it at 32. That doesn't make sense either. I'm gonna put 24 and we're gonna see what happens.
That's gonna test.
Okay, so in our data, the offset is 4, 8, 12, 16. The size is 2, and the value is the vertex, no, the normal index. Why are you complaining? Oh, it needs to be 0. Offset 18 is our vertex index. Um, Hold on though. Okay, I need to see what data we're actually getting back here. So I am going to jump back into runtime. I really need to add wrapping back to this menu. Let's scroll the entire way. All right. Let's see what we're actually getting here for values. So vertex index 0, normal index 1, and 2. That's not what I was expecting. What does this mean? This is base index 0. Zero, 1, 2. I'm just trying to reconcile this. Trying to make it make sense. Are we looking at the correct set here? Yes, we are. Actually, let me verify that. Oh yeah, no, it's number of faces 20, so yeah, we are looking at the right one. Are we getting these values, maybe? I think we might be getting those values.
Yeah. Because
So how do we read what we are looking for? That's all that we've got on here. That's everything that we've got on the face. Okay, let's take a look at what else we've got on the mesh here. So we're already looking at the faces. What is a primitive type here? Well, first let's see if we actually have any. Okay, it says there's 4 primitive types, so I'm not really sure what that means.
I think it is what we are looking like the split materials. I think. Yeah. M faces is telling the number. Okay. The real index is 0.
I'll be back in a moment.
Okay. Pretty much.
Okay, what is going on here? How do we parse this information? Number of UV components. Interesting that we get a buffer for this. We have 2 materials. I guess that must be those. Yeah, I think that makes sense. Oh, here, materials. Yeah, and that's referencing those textures. Okay. So that makes sense. I'm gonna see what I can find in the documentation that I was looking at here. So this is literally just loading the vertices one after another. That's not exactly what we want. This is loading animations. Mesh refers to its material in the same way as nodes refer to its meshes. Materials are stored in an array inside AI scene. The mesh stores only an index into this array. Okay. Series of data channels. Single vertex always has a position. May have one normal, 0 to a number of text coordinates. Okay, we don't care about bones. This is not very useful information, which I can't say is unusual. Can we go to Google, please? I'll leave JGL. Ask him. Yeah, let's take a look at Learn OpenGL, because this site's actually pretty good. This is a really good place to actually learn OpenGL, as the name might suggest. Okay, so what do we have here? It's kind of skipping over a fair bit of stuff. Let's see if we can actually look at the full source code. Should be able to. Actually, can we look at the mesh here? This might be. Okay, that's just OpenGL stuff.
Here we are. I finished now it's in a single material.
Ah, nice. All
It
right.
took me a while, but yeah, I find that some stuff for OpenGL and a simple library is like, I don't know if it's correct to say that it's lost some information, how to use it and that stuff. Okay, I think right now should be doing the trick.
All right, so let's fire this back up and make sure the numbers match what we expect. And I'm also going to take a look at the file while we're at it.
Now, as you can see, you will find only two, let's gonna say, triangles, one for each object, and that's all. Yeah.
Okay, so we got a breakpoint. Okay, so number of faces, we get
Must
10.
be 10, which is the number I
Scene
expect.
dot num meshes is 2.
Okay, now it's doing the trick correctly.
Yeah, so that seems to make a little bit more sense. That's going to work a lot better with what we're doing. Complete source code. Here we go.
Okay.
Nope. This is
The classic.
this is just OpenGL
Code.
code. I need the source code of model. Oh, here we go.
Mm-hmm.
Okay. So this is okay. So this is, I don't know, I guess kind of expected. It looks like the vertex and normals arrays just line up.
Yeah. Yeah, pretty much, I think. Um, as I did
Well,
in the.
hold on. We've got normals here with count of 30, and we've got vertices here with count of 48.
Yeah, because not always the normals are applying to the same in the same vertex. Could be directly to the face, or outside the face in the volume. You don't like make much like you don't get worried about that because uh, I suppose that a simp could handle that stuff internally.
Well, the thing is, I do need to worry about it because I need to apply them correctly.
Oh, okay. I didn't know that. Sorry.
However, interestingly, here I'm seeing number of vertices 30.
Uh-huh.
Um, and normals
Number.
dot remaining is 30. Vertices dot remaining is also 30. Okay, so here I guess they line up. So I
Yeah.
mean, that's fine. So how do we access this?
Yeah. Well, you got seems to be split by material in so I think you will look for indices or I don't know how a simp turn the like the structure from die into the same code. Maybe it's under indices or
So
under
it doesn't seem
faces.
it doesn't seem like that information is on the faces object,
Okay. So in
which
material will be that's yeah, material index result 0 expected because you have only one material, a number of materials.
actually we've got two materials.
Okay, yeah, makes sense because you're loading two different models in the like in the I mean not models, two different models, two different objects. So
Um,
even
mm,
if the same material will take two materials because one for each.
okay, so the material has properties,
Yeah.
but what does
They
that mean?
we yeah, much of the properties for materials are for the shading itself. So you will find that, for example, you got one material that can be shaded with a type of like um shading. I will let me oh, oh, let me going into this one because I don't want to be so clunky in my explanation. of Stuff.
Um,
Here it is. Okay, reference card. Okay. Um,
yeah, I don't think these properties actually give us what we want anyway.
no, it don't. It's only to the shaders stuff. It's telling what kind of calculations must be used for shading and that stuff. Not much more. Um, but I don't know why a simp is like loading the faces as like a kind of material. I didn't expect that. I expect to be like the object and other stuff loading into array. Uh, Very similar to the others arrays.
Let's walk through this a bit more and see what other values we get. 3, 4, 5. Really?
Yep, 3, 4, 5.
6, 7, 8. Okay, so it's just.
Yeah,
But what do those?
that's values are that are you looking at right
Yeah,
now,
but I'm trying to access these.
and you can't. Uh,
I can't figure out how to.
okay. Um, Face pointer, face index. The face in itself is not an array. Yeah, the face is the array itself. Seems to be. Face index 2 makes sense because it's the second face. In here, you will
But
find
it's
0.
just giving me like phase 0 is giving me 0, 1, 2. Phase 2 is giving me 3, 4, 5. Phase 3 is giving me 6, 7, 8
Oh
or
yeah.
whatever. And that's not
Yeah.
helpful. That's not helpful. Those numbers don't mean anything to me.
Yeah. Give me a sec. I will return in a while.
Um, Give me information on faces, please.
Okay. Free object, big camera, loading more complex model. 3D object. Yeah. iFaces code example. Mm. Mm. Let me
A single face
try.
in a mesh referring to multiple vertices. If number of indices is 3, we call the face a triangle. If number of indices is greater than 3, it's called a polygon. Can be queried to quickly examine which types of primitives are actually present in a mesh. The process sort by p-type flag executes a special post-processing algorithm which splits meshes with different primitive types mixed up, e.g. lines and triangles, in several clean submeshes. Furthermore, there is a configuration option to sort by p-type to remove specific kinds of primitives from the imported scene completely and forever.
Mm.
So this quickly examine which types of primitives are actually present in the mesh.
Yeah,
So
but
that doesn't seem like what we want.
yeah, we want to load all the data and read it from there. So mm,
Asmp get face vertex indices.
yeah, this person seems to run in the same spot. Uh, index buffer representation. Oh, oh, this is bad. Read the last sentence. As far as I know, it's not possible to access the original indices using a SIMP. Go! Oh my god.
Each unique vertex text core normal combination will give one vertex, while the index buffer points to this new vertex list.
It's like partially like preparing the data to OpenGL, something like that. And that destroyed that kind of manipulation, destroyed the original data.
So, I mean, that might be fine. It may just be transforming it into its own format, sort of.
Yeah.
Okay, so
So
we're looking at...
in this case, it's correct. The vertex index, normal index, and text coordinates are good. Say something because the async processor is like doing that way.
995447.
Uh, you can check in it. That's weird.
Hey Justin, hey Julio. Justin, we are in the process of importing a model from Ocarina of Time. And by in the process of, I mean struggling to.
check something. Library geometries. You will find the data for vertices in library geometries. What number give you the x value?
Hold on.
Because the file format is a little bit to read the first time you find it.
9.954448.
Yeah, it's correct. It's the first vertex. Yeah, it's correct. Nice. You got it. It's getting the vertex. That's because you're reading the materials part, library geometries. You will find in there in the mesh positions, source ID, big 30 chess 001 mesh position. You will find the mesh position will be the vertex position, actually. Yeah. Colada could be a little tricky on that.
The issue is, let's take a look at this. Actually, I'm gonna add a bit of logging here real quick. Recompile, and by the time we get in here, it'll be recompiled. Okay, so we do one iteration here, and we see...
Yeah, it's getting the first, the second. Okay, but it's changing some stuff.
Seven. Okay, and
One is the same. Okay, yeah, it's reading the square because you have to think that it's a box. So, oh.
yeah, see, so this is just not correct. Okay, so, hold on here. So, okay, so number of indices is in fact the face count.
Yeah.
So I think, I think this is just vertex indices.
Yeah.
Hey, $2 gargoyle. Right now we are currently hacking in a Legend of Ocarina of Time model into Legend of Dragoon. Okay. I think I understand what this is actually. I think I get it. Okay, so how do I do this? So we're gonna have AI vector 3D vertices base vertices base normals, and we're not gonna worry about texture coordinates right now.
What?
Okay, so in this space, okay, I'm going to move this in here. So we're going to index equals 0 space dot number of indices final vertex index. Okay, I think I'm onto something here.
Nice.
Equals mesh dot vertices dot get vertex index. And actually, sorry, this should be index. And then face normals, and this should be normals. Okay.
Yeah.
That is going to give us our face data.
Okay. Now
So
you got.
now, oh wait, we don't actually need that stuff yet. Actually, we don't need this all, do we? No, we don't. Okay. Okay, so this stuff goes up here. We delete this, and then we just need to do a little bit of math here. These are going to be the same values. Okay, so this is going to be 16 plus index times 4. And I think these are both going to be vertex index. Okay, so now we are going to int vertex index equals 0 mesh dot over vertices. And this is just going to be as simple as vertices dot add new s vector dot set and vector 3D vertex equals mesh dot vertices dot get vertex index. Okay, problem. We need to convert from floats into shorts.
Okay.
So we need, wait, okay, how do you convert from short into float in your tool?
In my tool, I do a little math, but you don't have to worry about that math because I just use this method from Python called int from bytes. Python int from bytes.
Well, we need to do the math that you do to convert from short to float, but backwards.
Okay.
To convert back.
Bytes. Okay. The argument bytes must be either via bytes-like object or an interval processing bytes. The byte order argument determines. Okay. Here is this. I think the part of the code. Let me review this one. I use this built-in code from Python to convert it. And then I apply the automatically Python take that and do the float thing. So
Yeah, can you link me to where you do it in your code?
yeah, pretty much. I will show you. YouTube. Oh shoot. Okay. Doing it wrong. Reduce. Coder. Um, you need the vertex decoder. I mean, I think I'm correct.
Yeah, the part that converts from the Legend of Dragoon short representation into the float representation.
Okay. Okay. You got the primitives. Vertex. Okay. Here we are. In the standard TMD decoder.py, you will find in the first part the vertex interpreter. Oh, why this? Oh, shoot, well, no problem. And you will find part of the math I use. Well, not exactly math. I use a built-in module to convert the short into um, integers, and then let me show you very fast. Um, I take this one. Um,
Yeah, I need the part that converts from integer into float.
yeah. I'm looking at it right now because I split from the main part of it while ago. Um, oh, shoot. I took in here. What the actual?
So I found where you're
Yes,
doing it to
I
colors.
yeah, I think the main problem is that I take the original code and split out in parts, and sometimes it's difficult to find, like in code, what I'm actually looking for. Um, right,
Yeah, this is
okay,
the CTMD
returning.
stuff.
Okay,
That's not
yeah,
what we're looking for.
yeah. Now I'm going this one. Into the compiler. I fear it's one of the last step I do. Collab writer, the collab writer. I think. Oh yeah. Oh, you gonna get some That's the timing here.
Did it?
I found it. Yeah, and actually you will find it in the
Is it just this
yeah
right here? Divide by 1,000?
yeah, exactly. The vertex in array 0, 1, 2, that's representing x, y, and z, and dividing by 1,000.
Okay.
Just like that.
Why 1,000?
Because the scale is pretty much, if you have it native, for example, Dart will be measuring like 1 kilometer, more or less.
Yeah, so that was
Not
just a
go,
value that you chose to
yeah,
that
to scale
looked okay.
down, and yeah, it's
Okay.
like one unit in T-load is approximately like yeah 1,000
All
meters.
right. In
Yeah,
that case, we'll just shift this by 10 and see how that looks.
yeah.
Actually, I don't know if you can even shift shorts or floats, I mean. No, you can't. Okay. Well, I'll multiply
And
by
anyway,
1024 by now. For now.
yeah, yeah. I think let me check this one. Well, yeah, where I get root 3.
And what about the normals?
The same. I think the same, but I do some rounding. Yeah, the normal's the same, but like that. Yeah, the same. 1,000.
Okay, this might take a little bit of tweaking.
Yeah, yeah, because as I said, I expect to do this scale into Blender, but in the reconverter, the idea behind is using the same scale to like amplify the model into the scale of the load. Instead of having like, I don't know, initially I got this value, um, 256, you know, uh, so anyway, for anyone interested in the code for the converter or models, I'm actually using like blueprint of the die file format into the code directly because loading stuff and doing more code fancy stuff in that time was very complex for me. And right now I'm not. It's not that like complex, but I'm a little lazy about changing that. Yeah, I prefer to have the control on the blueprint. You know, it's a little bit easy to find, at least for me, some stuff. Okay. Yeah.
All right. Yeah, scale is never actually even used.
Oh yeah. Scale
All
factor
right. Are
for.
you ready for this to not work?
Okay. or maybe it will work, but I I think something very funny will be happening.
Alright, so first we're gonna step through the code while it's loading. A, to see if we notice anything odd, and B, to increase the tension.
Yeah. Okay. Um. Okay.
It crashed by the looks of it. Yeah.
Yeah.
Okay. So we mathed wrong here. Let me take a look at those offsets again real quick. File formats. Doing 34. So this should be 4, 8, 12. Yeah. Okay, so I had offset those from the top here. But we don't
Okay.
include the command in that part.
Yeah. The command is ignore. I mean, why do you want to add a command each primitive packet if you can handle it from a single one command and like packet all in the same place?
Okay, so first breakpoint, second breakpoint. Let's we're gonna step through here and see how this looks. Looks like we crashed again.
Yeah, it's 1 second.
Yeah, okay, so let me recheck this. So 4, 8, 12, 16, 20, 24. Okay, so we're just gonna step through this line by line and see where it's going wrong. Gonna wear out my nose wheel.
You gonna buy a new one.
Okay, so our first one should be offset 12, which makes sense. Oh, this should be 14, of course.
Oh,
Okay, so we're just gonna recompile, hot swap this, jump back, and yeah, there we go. So it succeeded there that time. So now this should be our primitive packet. Those are our
yeah,
vertex indices and normal indices.
nice. Working for us.
Okay, so we got through that. We got through adding the vertices. We have 30 of them. Look at that, those
Nice.
look right.
Yeah, yeah, pretty
Okay.
much. I think the negative values are represented first with FFFF for FF, if I'm correct.
Oh, I
So,
just noticed this is wrong. This should
okay.
be normals.
Oh yeah.
All right. So let's just run it. See what happens.
Okay. Cross finger.
You ready?
Okay.
And we got nothing.
Oh, nice. Oh, maybe something very big. I didn't tell you, but I used the scale as natural in to load, not the other scale. So I think you're inside the treasure chest right now. I mean it. You're you're part of the treasure in the treasure chest. Script 8. Script 8
Why
is
does it have
is
0 for everything? This could actually be the issue right here.
okay.
I don't think it
I
all got set up correctly.
okay. rotation and position. Position. Your seat plus plus.
Yeah, let's set it to darts position 105, 50, and 630.
Okay. It will be the best. Okay. And scale. You can scale like invert the scaling in negative.
Let's see if it's really small. No, it's not really small.
Maybe very big, very big.
Yeah, let's cut that down. No. Cut it down a lot. No. Okay, so
we got
yeah, we are inside of it. We are inside of it.
Yeah. You can move it.
I'm gonna disable player collision there. Okay.
Now, what will happen? You can move it.
Well, yeah, we can move it, but it's not rendering, as far as I can tell.
Okay. Maybe something weird. I mean, this is a win because finally we got something rendering, but we can see it.
Yeah, so the question is it really big or is it really small?
Well, in my case, I used I didn't like it's very big for me because I took the original size of the model, and the original size for that treasure chest is like, I don't know, let's gonna say 4 meters, for real meters. So I do the same conversion into the molded treasure chest to the same size. So
It might be because we don't have the texture data. So I'm just going to use a solid render command.
maybe could be.
Yeah,
Surely,
so let's just use this here. Let's use this. So
and don't put it in black. Be sure that
yeah, I'll just make it pure white.
pure white or some other color, maybe red, something like that.
Alright, we'll make it bright magenta.
Yeah. Give me a sec. I will return. Wait.
Okay, so red, green, blue. And that is oh actually we'll use 30.
Right here. Sorry for the delay. I was doing some stuff right here.
Okay,
Well,
so this becomes
I mean,
4 and 6. Alright, let's
chocolate,
try this again.
chocolate saying beginning time.
Yep.
Yeah.
I actually it might be embiggening or end smallening time.
Yeah.
We aren't sure.
Ontario also said, so close. Yeah. Let's gonna. Oh,
Still
well.
nothing.
Okay. So you are using the scale Why you don't scale the model in that normal X? You can invert the scale, like put negative numbers.
Well, this is a
Or
multiplier, so and it's shifted
so
right by 12. So anything under 4096 will make it smaller.
okay.
Oh, right. I did just realize.
It's in the position.
Okay, so that is it there. So its scale is set to 0 right now. So let's just.
Okay.
Damn.
No. No. Thank
Okay, we're going to mess around with this a bit.
The weird thing is
Oh!
that you can collide. Oh! 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 Yeah, we got it! It's there! It's hiding behind the...
Yep. Okay. Here we go. Okay, we're gonna turn collision
Yeah.
off.
And you can see it. Nice.
You saw it here first.
Yeah, nice. Nice. It's there.
This
It's
is
purple.
technically a Legend of Zelda Ocarina of Time treasure chest.
Yeah. And it's open and it's using the sap, you know?
Yeah,
You can see it.
yeah,
Oh,
it
that's
is open.
oh shit. I didn't expect it to work so well. Oh my god. Oh, nice. We're getting ready. That's something that I'm a little aware is I think something messy with the you know
The normals are definitely messed up here
yeah,
because we're
but
seeing some inside faces.
exactly. Yeah, inside
It
faces
also
and
looks. I think the lid might be upside down. Or no,
okay.
it's just open really far. It's not
Oh,
upside
okay,
down.
okay.
I mean, it is upside down, but it's supposed to be.
Yeah, yeah, yeah. Yeah, because I do the arrangement of the objects pretty much like in using my
Okay.
eye, you know,
I'm
because
gonna
I have
disable.
no way.
I'm gonna disable backface culling. There we
Oh,
go.
here it is. Yeah,
So there's the whole treasure chest. In the Legend of
nice.
Dragoon world, you can see we can walk through the geometry. Yeah,
Nice.
that is
Oh, oh
something.
my god. I can't believe that actually worked. Yeah, actually worked.
Yeah,
Oh my god.
we got it.
Oh,
It needs a lot
I'm
more
so,
work,
I'm
but
so,
that's it. We are officially rendering a modern 3D model format in Legend of Dragoon engine. Or well, I guess it's the Severed Chains engine because it's heavily modified, but
yeah. At this point, yeah. But oh my god, that's very big. I know that this is so wow. Uh, Maybe we should try with something more simple. Because you know, it's like I sent to you um one like file that will be like a simple enemy, quotes, simple enemy. Maybe we should try in a time to like using that simple enemy, like replacing one of these villagers or someone like that.
yeah, the problem is it needs to match up with the animations.
Yeah,
Okay.
that's true.
So the normals are definitely not right.
Yeah, are inverted. Yeah, are flipped out.
I'm not 100% sure that that is the case. Um, because some of them are okay.
Correct.
I think what's going on here is that there's only one face for like there's only one face here. So like it's facing outwards.
Oh
So if
yeah,
we look at it from the other side, it's translucent, which is technically correct. Um,
yeah.
when you converted this model, did you remove some faces?
No, I don't. But recently I tweak a little bit the UV map, so maybe I don't think it will be the case. Maybe our normals.
Yeah, no, the normals are fine. But the reason that it's not rendering some of the faces is because the faces are pointing in a specific direction,
Yeah,
and it's using backface culling. So it's just culling those faces because they're facing in a different direction.
yeah, that's
So like
weird. And
if we turn this chest around, you'll see that the back wall will appear.
yeah, inside the
Which
chest. Oh, yeah.
actually
Uh,
looks like the back wall isn't appearing.
Yeah, because inside the it's like I will show you a pic of this. We'll see what's in here in the in the chat. You will find that the color red indicates that the face are looking inside, and the blue color for the model it's looking outside. You know, facing outside. So it's weird that you find that way. But I have to tell you something about the Treasure Chest original model. Maybe it's of your interested. Um, I find that they have the normal flip out in the model. Um, Let me check this very fast. Blackface cooling. Oh, here. Face orientation. Oh, yeah. No, it's not. In this case, are okay. I think it's in the white crates that normals are like. Oh yeah, no, are inverted. What the hell?
In the treasure chest?
Actually, yeah, in the original treasure chest are inverted. Are looking outside. It's like uh, to see the model correctly, you have to see through it. You know? Yeah. Look at this. This is the original model for the treasure chest.
Where am I looking?
That will be explaining why sometimes you see it like there it is.
Where am I
It's
looking?
inverted. Yeah, that's the original treasure chest
But
model, and you can see
where are you showing it?
oh yeah, in the Devstream chat.
Okay, let
Send
me
you
see.
the pic.
Okay, I see.
Comparing the red, like red color of the face indicates that it's facing inside, and the blue color is indicating that it's facing outside. No, um, in Tilot is backwards. It's
Maybe
totally
maybe your tool is generating them backwards?
no. No, I'm pretty much sure that I didn't touch the sign in this in
Okay.
here.
I don't know.
Uh,
No idea.
maybe that's why some issues with the with the 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 translucency in the game that you find sometimes.
I don't think we have any of those issues anymore.
Oh yeah, but in the first run I made.
Okay, so we are definitely making these way too big.
Yeah.
I wonder if we can just get rid of this multiplication.
Yeah, you will, you will, you won't need it. Also, the scaling of the normals will be the same. In this case, I'm using the same like units that Tilot use for the conversion into the ISO. If there,
Oh, this is gonna start this combat.
okay.
Alright, let's just rush through this real quick.
You need to rush the combat too. Boom. Boom. It's even possible to get killed in this first fight.
Is it? Because I always just spam through it when I'm testing, and it's always fine.
Okay. Okay.
Okay, so right, so the scale by default is 0, so I wonder what we're missing here.
Maybe something that the script is telling to the object to be set. Keep in mind that that part is scripted, you know, the scaling of the object.
Yeah, it
So
might be that. So I wonder if we should just default the scale. What were those values supposed to be used for? Oh, we did actually miss a bunch of code here.
okay, that will explain a lot of things going on, but
Right, okay, so it helps if we have the rest of the code.
oh yeah, part B invisible. That was
Okay, recompile.
must be showing. Okay, now it's showing at least without touching anything. Oh yeah.
So it does look a bit weird.
Yeah. Oh, it goes. Oh, it returns.
Somebody's mic is... Drew, are you there? Drew lost
Hello?
power for a while, and I think may have... Drew, are you there?
Hello?
Hi. Your
Yes?
mic was making a bunch of noises.
Sorry.
It's all good.
I was going to tell you, I think that the storm is happening because of what you're doing. Because right as you got underway with the transplanting, almost an hour ago or whatever, we got a huge storm, and it knocked out a giant branch in our backyard, and it hit our main power line. So for once, we were the result of the power outage that a lot of houses are now experiencing. So I think SOA is saying, don't do this, you're not supposed to get this far with LOD.
Well, that's too bad, isn't it?
Yeah.
So if you lose power after me, you know why.
Alright, I'll keep that in mind.
Okay, well,
Okay, so the parts are not quite aligned correctly
yeah.
with the animations. So we'll have to
So,
figure out how to fix that.
mm, and that simple calculation. I mean, I want to do something like a SAF model converter, but I want to be sure the way that the payload coders did. I think they used the volume of the objects to get the positioning in the 3D. Or maybe the first vertex is representing the point zero to that scene. Maybe it's that, but I'm not so sure.
Alright.
But
I'm going
everything,
to... I'm going to start a new game because I want to see what happens when we actually open the chest.
yeah.
And yes, you're right, you will not succeed. I didn't actually do a submap check to
Oh,
when I forced it to do the replacement. So it's just trying to replace every model with that, or every Model 8.
yeah. That's that's why I see that is in. Oh yeah, it changed in there.
Um,
Oh, oh yeah,
now, do we... We must have the submap index here.
yeah. Submap.
Okay, I'm just
Uh,
gonna comment it out and then recompile at a later time.
yeah, I got it. Yeah, because anyway, because the model is in the place are like hard code inside the script for sure. Um, I'm pretty sure that developers in the first try they try to do like things that models are repeating, just use one single model. But finally they decide to use like the repetition of models. Um, okay, in there you will need to do the check.
Yeah, I'm just going to, I'm not gonna open the
Yeah.
chest, and I'll just come back once I've re-enabled the code.
Okay. Oh, you're running to 10 right now. 10x. Yeah. Wild.
Alright, so
Now
we've
it's
got
time
normal
for
chest. Now we
yeah.
come over here, we re-enable the code, and
Gonna find out. Okay.
okay. So
Okay.
I'm gonna move it over a little bit.
Oh my god.
And let's see what happens. It moved.
Oh, it moved. It moved. Okay. Nice.
Yeah, so the animation does work.
Yeah. Yeah, yeah. It's working. Maybe it's something about the scaling. Maybe I miss a little the scale in there.
Yeah, it's definitely a scaling issue.
Yeah. Skill scaling issue.
um, so let's see kind of what scale we want this to have. Um, in the loader, I will change the scale a bit. So yeah, let's try just like ×3.
Yeah, will be enough to show.
Too big.
Too big. Maybe a scale of 2 would
Yeah,
be
I'm gonna
enough.
try 2. Yeah, we're getting a bit
Okay.
closer because this is a large chest. Remember, it's a large chest from Ocarina of Time, so it's supposed to be pretty big.
Yeah.
Like,
I.
if we take a look at a large chest. Oh my God, Bing. Why is it Bing?
Okay. There you go.
Like, I mean, like, look at how big it is, right?
Yeah.
Like, it is
Even
supposed to
for
be, it is supposed to be big, and I think we're at pretty close to the right scale here.
yeah.
It's
Maybe
hard to
it's
tell because it's not rendering very well, but
anyway. It's. I think this is a succeed in all the terms because Uh. I know how you hate doing hacky stuff for making it work, but it also shows something very similar to the like also. Oh, nice. Changing the colors. I wonder if you could load with the texture right now.
that will take a lot more work.
Yeah, I'm pretty sure because even with the thing going on with the
I was
with the
hoping
from
that shading would work. I think the normals might not be quite right in general.
yeah, I
Um,
will
so yeah, I
loading
think they're not
for
quite
the
right in
pillar.
general because the shading is not working.
Yeah,
Because this should be Goro shaded.
yeah. Garage shader, no texture, solid, RGB, normal one. Oh yeah. You have to make like oh, wondering if the problem won't come from the how the because you got um give me a second. I need to check what type of primitive is using the original. Well, light
Eh,
source calculation for vertex, Gora texture, solid, translucent, and no translucent. Oh, why is using translucent?
I don't know.
What the hell?
But yeah, I
But
mean we're using light and everything. Like it should be getting shading, but
yeah.
it's just not.
Okay. Well, this will explain a lot. I didn't expect in the original model to find that it's using solid translucent. Oh, okay. Translucency in a treasure chest, you know, general.
Yeah, I mean that shouldn't really matter.
But oh, there it is. Oh,
Okay,
you are
so
working.
it might be too small.
Yeah, I
It's
think
really
that.
hard to tell the scale
Yeah, I
in these
think
kind of
maybe.
pseudo 3D environments. I think 3 times might actually be more correct.
Yeah, that's why I want to tell. For sure, 3 times is best
Yeah.
because you are getting into a large treasure chest, so I expect something very big instead of.
Yeah.
Oh yeah, and the positioning, maybe I missed something in there because, well, as I say, when I take the model and convert it into die file, I took as reference the original model of the treasure chest and tried to place the objects in the same spot, but it's something like very difficult to do uh, without a range of 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 error.
Yeah, like
Yeah.
we don't actually know the correct values, really, like the correct sizes.
Yeah. Anyway, I'm planning to have a soft converter too, so in the moment I got working, it would be easy to do this kind of stuff,
Yeah.
doing or animations. Also, I find like a way to trick Blender to get the models animated using an skeleton, a rig, but actually writing the data for as a file, like positioning the objects in the place. So I think